Good morning, natural science learners. I am Mr. McDonald Kesekile from Kimberley Technical High School. So I'll be presenting to you the first topic of the second term in terms of your CAPS. Remember, I've always mentioned to you that the CAPS is our guiding document that outlines the program of teaching to us teachers, to you, the learners. So last time when we were doing photosynthesis, we looked at respiration, and we also looked at different other interesting things with regards to photosynthesis. So that was some part of biology, but we'll talk about it again later on in this specific lesson. So on this year, we're going to look particularly at chemistry. In the section of chemistry that we are going to look at, we are going to look at atoms. We're going to look at what makes up atoms, or with what are atoms related. So now our focus here. So topics of CAPS, like I said, we use the CAPS as the guiding document in terms of what we must teach and so on. So some of the topics that we're going to look at for the rest of this topic of atoms, which is going to take us about 2 or 3 weeks from now on. So we have the subtopics and the atoms are going to look at atoms as the building blocks of matter. So we are also first going to define matter, look at what is matter, and in our process of defining matter, we'll also look at some of the things that you've learned in the previous grades, in particular grade 7. We'll also look at the subatomic particles, which are actually the parts that makes up an atom. You see, when you look at the word subatomic, so the word atomic comes from the word atom. So we'll actually look at what exactly is within an atom, or what exactly makes up an atom. And then later on, we'll look at pure substances, we look at elements and compounds, and then we'll also, as a concluding section under atoms, we look at mixtures of elements and compounds. Now, let's get into our discussion around atoms. The first thing, before we come into atoms, let's look at some of the things that you've done in grade 7. For an example, in grade 7, you looked at elements and compounds as pure substances, and I'm sure at that time you were able to define pure substances to be chemical substances that cannot be broken down into any simpler substances. And examples of pure substances then were elements and compounds. Now, all elements, we also taught that all elements that we know of are arranged in what we call the periodic table of elements. And elements form the basis of all natural and man-made materials. But on a daily basis, we interact with various materials, and we know little that all of these materials that we're using, they have got within them elements. For example, the oxygen that you breathe to live and to survive. Oxygen on its own is an element. We're going to look later on when we look at the periodic table and some of the elements that are found in the periodic table. The oxygen that you breathe is an element on its own. The water that you drink is made up of 2 elements. It's made up of hydrogen as well as oxygen. The air that you release, or the wind, or whatever that you release, it's carbon dioxide that comes out of your lungs, out of your body. Carbon dioxide is made up of 2 elements, carbon and oxygen. So on a daily basis, we interact with elements. And you will also see as and when you gradually continue from grade 8, grade 9, up to grade 10, you will go deeper into various elements and their daily uses. Then, so elements form the basis of all natural as well as man-made material. We look into that. So the lesson objective here is, at the end of this lesson, a learner should be able to explain and demonstrate what an element is made up of. So, in as much as we're going to look at atoms, we're going to look at what exactly makes up an element. And you as a learner, you must be able to explain as well as demonstrate what an element is made out of. So let's look at revision of what we know. the revision of what we know. For an example, we look at that material there. Some of you can clearly see that those are copper joints or copper wires that are either used in plumbing or in electrical connectivities. But that's copper. So that's a copper material. It's what some of you come across. Some of the electricity in your houses is wired in copper. And you might also know that some of the other people who steal copper for money, we refer to them as the easy knockers. Those who steal our electricity, or those who even break down large electricity connections so that they are able to get out what we call the copper. So copper is a very costly and prestigious element. Much as we use it on a daily basis, it is an example of an element. So that is a copper wire. What other one is this? Some of you brush your teeth once, some of you twice, some of you 3 times a day, but we all use what we call a toothpaste, whether it's Colgate, whether it's Aquafresh, whether it's Sensodyne and all that. All of them gives you a white foam, and that white foam is an indication of the presence of fluorine. So your toothpaste has in it fluorine, and when you go to a periodic table of elements, you realize that fluorine, which in other daily use is referred to as a fluoride powder or fluoride or fluorine. It is an element, and it's also listed in our periodic table of elements. So we use elements as well as other compounds that are also made up of elements in our daily use without even recognizing that we are using elements. And yet, some of you, when it's December, when you've got festivities, you dry meat, you cook outside, and most of you use what we call coal, which is a natural resource. We get it naturally, and coal is made up of 75% carbon. Meaning when you look at all the material that makes up coal, 75% of which is carbon, and carbon is an element. So whether or not we like it, we are surrounded by elements, and we use elements on a daily basis. The elements are part of us. So let's continue. In term 1, we discuss the process of photosynthesis. So we are still trying to justify why we say elements are part of us and elements are around us. Whether or not we like it, we are surrounded by elements, and we use elements as for our daily use and also for our own personal survival. For an example, carbon dioxide, which is the gas that comes out of you that is taken up by the plants for photosynthesis. It is made up of 2 elements, carbon and oxygen. These are 2 elements found in a carbon dioxide. So carbon dioxide on its own is a compound, but it's made up of 2 elements, carbon as well as oxygen. Water that you drink, that plants take up through their roots from the soil, the water that you use to bath yourself, the water that we use for many other uses on a daily basis. Water is made up of 2 elements, made up of hydrogen and oxygen. So that now, those elements is also what we use on a daily basis. We breathe in oxygen. Water and oxygen and hydrogen, when it's combined, they give you water. So there's no way we can run away from elements. We depend on elements for our survival. Now let's go back. Now atoms, what are the atoms? Now we've been talking about elements, and now we want to remember I said the objective is for us to be able to explain and also demonstrate what is it that makes an element, or what is it that an element is made up of. So have that in the back of your mind. Now we are coming a little bit back. We go to atoms. Now, you see, atoms are referred to as the building blocks of matter. Whew, what is matter? That word is underlined and written in bold. What is matter? Let's go back to some of the things that you were taught in grade 7. What is matter? You have learned from earlier grades that everything around us is made up of matter, or it's matter. This highlighter is a piece of matter. This calculator is a piece of matter. The desk that I'm sitting on, that I'm using, is a piece of matter. The oxygen that you breathe in is matter. Then the clothes that you wear is matter. The air that you breathe, the water that you drink, all of them are made up of matter. Matter makes them up. Or they themselves are also an example of matter. Matter is everything that has mass and takes up space. Meaning, if I take this highlighter and put it on top of the table, it's going to take some part of that table. So that's the space that this highlighter is going to occupy. When you are seated on that chair, you are taking up space. So it means that you are an example of matter, and you also have got mass. When you go and stand on the body mass, you get the size of your body. It can be 54 kilograms, 60 kilograms, 42 kilograms. That's the mass of your body. And because wherever you walk or wherever you're standing, you are taking up space on the ground or on the floor or wherever you find yourself. So that means you're an example of matter. Even a piece of hair, when you take it out of your head, a piece of hair, and you look at it, it looks very light as if it doesn't have mass. It does have mass, but its mass is very, very, very small. And when you take that piece of hair and put it on top of the table, it does take some part of space. So it means that that hair is also matter. A feather that comes out of a bird, as light as it is, it has got a mass and it also takes up a space. So it's also an example of matter. All matter is made up of tiny particles called atoms. Now that's where we are getting to. All matter, all types of matter. Matter that is got mass and space. This highlights the food that you eat, the oxygen that you breathe. All types of matter is around us is made up of smallest particles. And those smallest particles that makes up matter are called atoms. So all matter is made up of tiny, small particles called matter. Now let's go back to the first bullet. The first bullet says atoms are referred to as the building blocks of matter. Okay, let's look at this simple demonstration. Let's look at this simple demonstration. Let's try to draw up something. Let's say, for an example, this block here is a piece of matter. Now, what makes up this block is tiny little other blocks. Let's just try to do that. It's a tiny little other blocks. I'm sorry for the inaccuracy of my diagram. Yes. So when you look at this, so all of it here, all of this here is an example of matter. That block in there is an example of matter. Now it's made up of small other tiny particles. So we can argue from here to say, if this big block here on its own is an example of matter, then it is made up of small other square-like or rectangle-like particles that are formed within there. And those small things there, those are the building blocks of matter. It is the smallest thing that makes up that matter. So all of those small things that have came together, they make up a piece of matter. Right? So, yes, now let's go back to our slide. Yes. So again, so atoms are referred to as the building blocks of matter. And at the same time here we are saying that all matter is made up of tiny small particles called atoms. So these two statements are the same. They mean the same thing. Atoms are the building blocks of matter. At the same time, matter is made up of tiny small particles called atoms. So no matter how you define atoms, you can either say that atoms build matter, or matter is made up of small tiny particles called atoms. It's like a human being. When a human being is standing straight up, it's still a human being. When you take that person and put him the head down, feet up, it's still a human being. It's just that the position has changed. Are we together? Let's look at another example here. This is a bag of marbles. A bag of marbles. So the bag of marbles represents matter. And this bag of marbles has in it many other marbles. So each and every marble there is an example of an atom, because it is those marbles that makes up the bag of matter. So if these marbles are not there, you would not regard that bag as an example of matter. So if this bag represents matter, these little tiny marbles in here, they represent what we call atoms. In the little marble bag above, the bag itself represents matter and is made up of marbles or atoms. Remember, atoms are the building blocks of matter, or you can simply say that matter is made up of tiny small particles referred to as atoms. Now let's go back. What is an element? We said that elements are all over around us. We are surrounded by elements. We are surrounded by elements. We breathe in elements. We breathe out elements and compounds. So what is an element? Like any other form of matter, an element is also an example of matter. Remember I said to you, oxygen is an example of matter. I said to you, whatever you touch, whatever is around us, is an example of matter, because that thing occupies space and at the same time there's got mass. So an element is an example of matter. An element is an example of matter. Oxygen we breathe in is matter, it's an element. The fluorine in our toothpaste is matter. Copper wire, it has mass. It's a piece of matter. The copper wire has mass. The copper wire has mass. So it is a piece of matter because it occupies space and also it has mass. So it's a piece of matter. So an element is an example of matter. So just like all the other examples that we gave of matter, an element is also an example of matter. All matter is made up of tiny particles called atoms. Now let's try to breathe in and out. An element is an example of matter. And we've said that atoms make up matter. So that simply means an element, as an example of matter, it is now also made up of atoms. Because an element is a matter, and that atoms are building blocks of matter. So it simply means that an element, it has got atoms as its building blocks, because an element on its own is an atom. Right? Similarly, elements are made up of atoms, because an element is matter. An element is matter, and matter is made up of atoms. It simply means that elements are also made up of atoms. So now that's going to be our discussion from here. Or now we're going to look at the atoms of an element. We will not look at the atoms of our highlighter, the atoms of the table, the atoms of the calculator, and all that. We will now look at the atoms of elements. Remember now our focus is going to be chemistry. We're going to look at chemistry. We're going to look at the behavior and the nature of atoms inside of an element. That's what we look at. Now, all atoms of an element are the same. Okay, before we come, it says, remember we said that elements are made up of atoms. Now we're saying here, all the atoms of an element are the same. Let's look at what that means. That means, let's take copper as an example of an element. Copper as an element. Or let's take oxygen as an element. Oxygen is an element, so oxygen is matter. So it means it has got tiny building blocks called atoms. Now, these atoms of an element, of this specific element, are the same or identical. Meaning when you look at the atoms of copper, all of the atoms that make up copper, they are identical. All of the atoms that make up oxygen are the same or identical. When you look at fluorine as an element, all the atoms that make up fluorine are identical. When you look at hydrogen, all of the atoms that makes up hydrogen are the same. When you look at neon as an element, all the atoms that makes up neon are also the same. Yeah. Let's look at this diagram here. That means atoms of one element differ from the atoms of other elements. Let's explain what this means. Remember, a periodic table has got all the elements that we know of. And one element, let's take hydrogen. One element, when we look at our periodic table here, one element, for example, let me just do this here. So when you look at all of these other elements here that are found in the periodic table of elements, let's take for example hydrogen. All of the atoms of hydrogen are the same. All the atoms of helium there, they are the same. All the atoms of lithium, all the atoms of beryllium, all the atoms of beryllium are the same. However, the atoms of hydrogen are not the same as the atoms of helium. All the atoms of lithium are not the same as the atoms of hydrogen, particularly because these are different elements that have different chemical properties. And these atoms, all of them, they function differently. They are in different states. Let's say, for example, copper, which is here. Yeah, let's take for example chlorine. In most cases, chlorine appears as a powder. That's what we call a chloride powder. And you take for example oxygen. Oxygen is a gas. Chlorine is a powder. So these two elements have got different properties, they've got different chemical properties. They also function differently. So as that difference in terms of how they function or how they behave is particularly because they have got different atoms. So all the atoms of oxygen are the same. However, the atoms of oxygen are not the same as the atoms of chlorine. All the atoms of chlorine are the same, but the atoms of chlorine are not the same as the atoms of oxygen. So in a nutshell, each and every element here found on the periodic table of elements is unique in the sense that it has got different atoms. Lastly, I repeat. Here we have got a table, a periodic table of elements. This periodic table of elements has different elements. And now, you have got hydrogen up until to the last element. Hydrogen has got its own atoms. Helium has got its own atoms. Lithium has got its own atoms. Beryllium has got its own atoms. So, the atoms of beryllium, all of them are the same for beryllium. The atoms of lithium, all of them are the same. But the atoms of lithium and beryllium are not the same. And that difference goes for all of the other elements on the periodic table of elements. Are we together? Yes, let's go back to our slide. Let's go back to our slide. Let's continue. Good. So now let's take two elements as an example. For an example, you take helium and carbon. When you look at helium, there is two rings. It's this ring as well as this ring around the center of helium. Now, this whole thing here is just one atom. This is one atom. This is an atom here. All of it is an atom. Now, these rings, they are referred to as orbitals or energy levels. So these rings are referred to as orbitals or energy levels. And inside of the ring, you will find that blue portion here, which is referred to as an electron. So each and every ring will have an electron, and those rings, they allow for what we call an electron spin. That we will see at a later stage when we discuss it. So this now, on its own here, is an atom of helium. It's just one atom of helium. Carbon, look at it. There's many rings around it. I can't even count them. 1, 2, 3, 4, 5 rings around the center of carbon. Look here. At the center of helium, there's only 2 small little balls. I mean 4. 1, 2, 3, 4. But when you look at the number of balls in the middle of a carbon, and by the way, the center of an atom is referred to as the nucleus. We're going to discuss that later. The center of the atom is referred to as the nucleus. And the nucleus is surrounded by various orbitals. And these orbitals, we also call them energy levels. And within each and every energy level, you find there an electron. And now those electrons will move around to the various energy levels. And the moving around of electrons on an energy level, we call that an electron spin. Right together. So look at these 2 atoms. You can see definitely they are not the same. They are different. This atom here of helium has got 2 rings, 2 electrons, and there's 4 balls in the middle. This one has got a bundle of balls in the middle. It has got many rings. It has got many electrons around it. So these 2 atoms are not the same. Now helium on its own, it has got many, many atoms that are the same like this. Carbon has got many, many of these atoms. These atoms, the atoms of carbon cannot be the same as the atoms of helium. The structure is different, the function is different, the electron spin is different. Good. So the sketch above shows 1 atom of helium and 1 atom of carbon. This is just 1 atom of carbon, and this is just 1 atom of helium. Helium only has 2 rings or 2 orbitals. The orbitals or the rings around the center, those are referred to as energy levels. And the center, both centers here, these centers are referred to as the nucleus, with only 2 electrons on each orbital. Carbon has many orbitals, so it has got many rings. It has many electrons around its center. Can you see the difference? Look closely at the difference there. There's only 2 rings here, there's many rings there. There's only 2 electrons there, there's 1, 2, 3, 4, 5, 6 electron spins. There is 1, 2, 3, 4 balls in the nucleus. There's only about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 balls in the center of the carbon. So there's a difference in the atoms. Remember, atoms are the building blocks of matter. An element is an example of matter. So that means if helium and carbon are examples of matter, helium is made up of the smallest units referred to as atoms. And those smallest units are the atoms that makes up helium. Here are those atoms. This is just one example of the atoms that makes up helium. Carbon is an example, is an element. An element is matter. Matter is made up of atoms. So here, the atoms that makes up carbon, the matter. Here are the atoms that makes up that carbon. Good. Elements, like we discussed, elements are pure substances. That means they cannot be broken down into 2 or more simpler substances. You can't take an element and break it down by any chemical means. You can't do that. It's a pure substance, a naturally occurring substance. And all known elements are listed on the known periodic table of elements. So this table here, which is similar to the one that I just made a demonstration on, is referred to as the periodic table of elements. Now let's look at what do you find. So on the periodic table you find various elements. Now each and every element has got information to it. Let's take one element as an example. For an example, let's take Fe, which is iron. On top there's a number, and then here you'll have the full name of the element, and then there you'll have another number. So what happens is, this here is referred to as the symbol of the element, Fe. That's the symbol of the element. And often just under the symbol, you will find there the full name of the element. And then the number on top there is referred to as the atomic number. And then the number at the bottom is referred to as the atomic mass of the element, because these elements are also got mass. So atomic mass simply refers to the amount of smallest unit atoms that are found inside of that element. That's why it's called the atomic mass, the amount of atoms that are found in there. Then, so that's it. So for every element, you can see for every element there, there's a number on top, and then there is also a full name there, and then there's many other information. So periodic tables differ from one to another, and many other periodic tables might give you more information. Some might even give you the SPD notation, some might even give you the ionization number, and many other information. So, but what you might find in general on a periodic table, you might find the atomic number of the element, you might find the atomic number of the element, you might find the symbol of the element, which is iron, and you'll also find the name of the element. In this case, it's written in full, it's iron. And then you'll also find what we call the atomic mass. And this periodic table you've been using from grade 7, you'll use it throughout your grade 8, you use it throughout your schooling career, and even when you go to university, you'll still use the same periodic table, however, at different intensities. So, ladies and gentlemen, our next lesson, we are going to look at the subatomic particle. Let me introduce you. So, the next lesson now, we are going to look at what is found in an atom. Very interesting lesson. Don't miss out. I'm going to look at what is in the middle there. I just said to you that is the nucleus. But what makes up the nucleus? What is there? Those few balls there. What do we call them? What do they represent? And here, what do we call this? Why do these ones have to be there? And why do these other ones have to be there? And so that's the subatomic particles. We look at what makes up an atom. What is in an atom? So in conclusion, now you know. An element is an example of matter. And an element is made up of tiny smallest particles that are referred to as atoms. No.